Hi, good day everyone. So today we'll be doing January 2019 number 3, paper 2. Number 3 says draw using a ruler and pencil and compass and a pair of compass. Construct a right angle triangle ABC such that AB is 5, angle ABC, that is angle B, is 90, and BAC, that is angle A, is 60. Alright, so first off they told you that AB is 5. So I'm going to use my ruler here and I'm going to calculate 5. So from, oh, not here, let's use the line. So from this line here, we want 5. Right? Right. So then I'm going to remove my ruler. I don't need this anymore. And I'm just going to label the sides A or B. It's all up to you which one you want to do. Which side you want to be A and which side you want to be B. So I'm going to put A here and B here. What did they say about B? B angle ABC is 90, so angle B is 90, and angle BAC is basically angle A is 60. Now they told you to use ruler and compass only, so you cannot use a protractor. Now the most important part when you're making these angles is that your protractor is open more than half the line. I'm just gonna make it like this is 5, so I'm gonna make it like 4. Step 1, to make it a 60 degrees, you draw an arc. Right, your next step is from that arc here that intersects the line. You draw next arc, and where it intersects would be 60 degrees. So this angle here is 60 degrees. You're gonna draw a line. Right? So this is 60 degrees right here. Doesn't matter how long you draw the line, we will find out or locate where C is located. Right? Let me draw that. I think I might have to draw it a little bit longer. Right? Alright. Right there. Then you're gonna draw your 90 degrees angle at B. So you're gonna take your compass. Again, don't open up your compass more than half the initial line. You're gonna draw an arc. Let's draw an arc here. Right. Then where it intersect there, you're gonna draw a next line that intersects that first arc, that is right here. Right, and then from that where it intersect that intersection here, you're gonna draw an arc on top, just like so, and also you're gonna draw an arc that is intersecting that initial arc you drew to make a 90 degrees. Right? Then you're gonna take your pointy part, put it here, right? And then draw an arc intersecting this first arc up here. Right? This and the initial line of B is going to be 90 degrees. Right? Now because of, I'm going to just bring this down a little bit, the whole image a little down, because you see that there's no intersection there, right? Between the line for your 60 degrees and your line for your 90 degrees. So let me just bring everything down and then we will try to make that intersection. Right, so you're bringing it down, right? Because you have space. And that initial line where 60 degrees, I'm going to just draw back that line. Right? And that line for 90 is drawn back, and you see that it's intersecting right here. So that location of where the intersection for your angle for 60 degrees at A and 90 degrees at B is going to be called C. And that is how you would draw angle ABC. Right, let's do the next one. Part B, let's zoom in. Says the diagram below shows a right angle triangle with units A, B, and C. Using the diagram, express C in terms of A and B. Well, C we know is our hypotenuse, right? So again, C is known as our hypotenuse, right? And what do we know about a right angle as hypotenuse? We know hypotenuse squared is equal to the two other sides squared. So side 1 squared plus side 2 squared. So this is going to be C squared is equals to A squared plus B squared. And if you just want C, it could be the square root of A squared plus B squared, if you want it like that. But that is the relationship between, to express C in terms of A and B. Write down in terms of A, B, and C and the expression for sine theta plus cos theta. Now, sine theta, or sine, is opposite over hypotenuse. Cos theta is equals to adjacent over hypotenuse. Right? So we know that sine theta, so sine theta is the opposite. If they gave you that theta was here, so opposite A is now your opposite, and B would be your adjacent, according to this diagram. So it would be A over C, right? Your opposite over your hypotenuse, and cos theta is going to be adjacent, which is B over hypotenuse, which is C. So when they say write in terms of A, B, and C, the expression for sine theta plus cos theta, it is going to be A over C plus B over C, which is A plus B all over C. And that would be your answer for this question right here. And the only reason I can add these two on top is because the denominators are the same. They're both C. Okay, let's go ahead. And the next question says, using the results from part 1A and B on page 12, show that sine A theta plus cos A theta, so I think sine theta squared plus cos theta squared is 1. So first off, they say we know that C is equal to the square root of A squared plus B squared. We also know that sine theta is A over C, right? And cos theta is B over C. So if I'm squaring this, square this, and then I also square this, it's going to be A squared over C squared and B squared over C squared. So let's add this up. We know this is going to be A squared all over, instead of C squared, I'm going to put this, the square root, 1 second. So I know A squared over C squared plus B squared over C squared. We want to know what this is equal to. Now this could be A squared plus B squared all over C squared. Right? Now, what do we know about c? We know c is this. So therefore, this is a squared plus b squared all over the square root of a squared plus b squared all squared. Now, the square root and the squared sign would cancel out each other, right? Or you could just say that this is a squared plus b squared to the power of a half, right? Because square root is to the power of a half. So let's do it. This is a squared plus b squared over a squared plus b squared to the power of a half all to the power of 2. A half by 2 is 1. So that's why I said the square root and the squared cancels out each other. So now you have a squared plus b squared over square root sign is removed, a squared plus b squared. Which when we divide, you're going to get 1. And that is how you would do this question here. Right, that's how you would prove that sine theta squared plus cos theta squared is equal to 1. And that is the end of January 2019.